In this video, we're going to look at expressing a sine theta plus b cos theta in the form r cos into bracket theta plus or minus alpha. You're going to do such kind of questions in your exams, and we're going to have a step-by-step on this, on how you're supposed to go about these kind of questions. We are told to express root 6 cos theta plus 3 sine theta in the form r cos into theta minus alpha, where r is greater than 0, and also we are told that alpha should be between 0 and 90. We're supposed to state the exact values of r and give alpha correct to 2 decimal places. If you are new to Proflan YouTube channel, consider subscribing so that anytime we're going to upload future tutorials, you'll be notified. We're going to have a step-by-step process on how you're going to go about this question. So the first thing we're going to do here is by understanding the fact that r cos theta plus alpha can be expanded. So let us first start by writing the expression the way it was, and then we say that is equivalent to r cos theta into cos alpha plus r sine theta sine alpha. So meaning that we can now equate the coefficients. We're going to equate the coefficients of cos theta and sine theta. So this part is going to be equated to this part because those two terms are having cos theta, so that we can be able to cancel it out. So we can write this part equals to this, and therefore we can now cancel cos theta, and cos theta will remain with this particular value. So we can say we are going to remain with root 6 equals to r cos alpha, which is our equation 1. Then the second part here and this one are also going to be equated so that we can be able to form the second equation that we're going to have. And then we can now cancel sine theta out, sine theta and sine theta cancelling out. We're going to remain with of 3 equals to r sine alpha, and this becomes our second equation for this particular problem. So meaning we're going to solve these two equations in order to work out the value of r and the value of alpha. Now let's go on, and this is going to be equation 1, equation 2. Now the first thing to do, let us now try to work out the value of we begin with, to obtain r, we are going to square the two equations and then add them so that we can be able to get rid of the trigonometric ratios. So we are going to say if we square the first part, we are going to have what? Let us square this. If you square root 6, it becomes 6, and this becomes r squared cos squared alpha. If you square 3, it becomes 9 equals to r squared sine squared alpha. So these particular terms that we have here, we can be able to transport them down here so that we can be able to add them as we agreed. So which means that if we add these two, we are going to get this particular expression, meaning that if we add these two equations, we're going to have this as, yes, I believe that now makes a lot of sense, because we're going to say 6 equals to r squared cos squared alpha. Down here we shall say 9 equals to r squared sine alpha. Then we add the two equations. You can see now we have 6 plus 9 and also r squared into bracket this way. Yeah, so okay, now we can be able to add 6 and 9, and this is going to give us 15, right? And then also we, on the right hand side, we are going to factor out r squared, so that we are going to form an equation that is quite familiar. Yes, you can see whatever that is in bracket is quite familiar. It means something. I believe you remember that is equivalent to 1. Therefore, on the right hand side, anything that is in the bracket can be replaced with 1. So we end up having this expression as r squared equals to 50, which we are going to find the square root, and our r becomes root 15. So we have found the exact value of r, we need now to go ahead and use the two equation that we had obtained in order to get the value of what? The value of alpha. Now to find alpha, we are going to divide the two equations. Now we are going to divide equation 2 by equation 1 so that we are going to have a tangent here, and this is going to reduce to tan alpha so that we can be able to say, okay, let us have a look at our equations. This was our first equation and the second equation was there, right? So we can be able to now move down here so that we can divide the two equations as said. Equation 1, and then we have our beautiful equation 2, meaning that if you divide equation 2 by equation 1, we're going to have what? We're going to have this written like this, and then divide by root 6 divide by r cos alpha. And you can see now the right hand side is going to cancel, r is going to cancel out, and we are going to remain with 3 over root 6 equals to sine alpha over cos alpha, and sine alpha over cos alpha can be replaced with tan alpha. So meaning now the next equation we're going to replace that with tan, and for us to find alpha we're going to find the tan inverse of that particular part so that we can be able to get our final answers 50.77 degrees. So we have our alpha, we have our r, then we're going to express the given original equation in the form that was expected. So let us go straight and do the same. So this is root 6 cos theta plus 3 sin theta can be expressed in the form that you were told. Inside the bracket we're going to write the value of alpha that we got. So basically that's what you are supposed to do, and I believe you have followed through what you are expected to do in this sort of questions. There's part B here, hence you are supposed to use the part that you have obtained in order to solve this kind of an equation. So this is equivalent to 2.5. Let's say 1 over 3, yeah, 1 over 3x plus 3 sine 1 over 3x equals to 2.5. This is the equation that you are supposed to solve. Now, if you look at the previous question, whenever point we have 1 over 3, or where we were having theta has been replaced by 1 over 3x. So that's quite profound because we are going to take note of that. And you are supposed to solve this within the range given here, x less than 360 but greater than 0. So something that you need to remember is that in this part we can be able to replace whatever we have on the left hand side with whatever we had obtained in part A, which is root 15 cos theta minus 50.77. But we are given here our theta is equivalent to 1 over 3x, 1 over 3x. So where we have 1 over theta in the previous expression that we expanded, we're going to replace that with 1 over 3x. Now let us use that part so that we can be able to replace that. So instead of theta, we're going to write 1 over 3x minus 50.77 equals to 2.5. Now, when you are at this particular point, what you're supposed to do is to divide by root 15 both sides so that we can have a process over which we are going to work out the values of the angles within the range that you were asked. So if you divide that, you are going to cancel this out, and then you are going eventually to remain with cos 1 over 3x minus 50.77 equals to 2.5 root 15. Now, I want you to pause for a moment because we are having, on the right hand side, we are having positive 2.5 over root 15. Now, we are going to find our angle we are going to find our angle within the quadrant where the values of cosine is positive. What I'm saying is, whenever we are going to find these angles of x, we're going to find them where the cosine, the quadrant where cos is positive, and cos is positive in the first quadrant and also in the fourth quadrant. Then before we move to the next step, I would like to mention that at this particular point, what we did, we divided by root 15 both sides, and in the second step here, we are going to find cos inverse both sides, so that we are going to have the cos inverse of this term here. And I mentioned that we are going to find cos where the angles of x are going to lie where cosine is positive, and that is in the first quadrant and also in the fourth quadrant. Right, moving on, we need also to ascertain that if you find the cos inverse of that using your calculator, you are going to get your final answer as 49.80. Then, which means that we can be able to now let us draw our quadrants here. So we have gotten our angle at that particular point is 49.8. So the first value of the angle will be lying in the first quadrant and also in the fourth quadrant. So if we have gotten this particular angle here, which is 49.8, that angle can also be measured in the negative direction to be 49.8 down here, so that we can now say, in order to find the first value of x, we can now go ahead and use that 49 the way it is by taking 50.77 on the other side of the equal sign. We can now be able to say this is 1 over 3 x equals to what? If you try to add what is on the right hand side, you are going to get 100.57 times 3 both sides. We are going to get our value of x as 301.71 degrees. That's one of the solution of the value of x. Now, another solution is going to be from the fourth quadrant, and we say now if that angle is measured towards the negative direction, it will be negative 49.80. So x values will be in the quadrant where cos is positive. So that's what we had said, and I'm just emphasizing that. So meaning we had gotten our quadrants to be the first and the fourth quadrant. We had gotten the first angle being 49.8, this part 49.8, which is positive, and the negative one is negative 49.8. So basically we can now go ahead and say we had done that step, yes. So which is going to be 49.8. Already we have done that, but we have also used that. So this part is negative 49, this part is positive 49.8. The lower part is negative 49.8. So we are going now, we had used 49.8 in the previous step. So we are going to use this other part here and say equivalent to negative 49.80, which will mean that we can now subtract the 2, and if we multiply by 3 both sides, we are going to get our answer as 2.91 degrees, and this becomes the second solution for that. And we end up at this particular point where we can conclude and say the value of x was having only 2 solutions. And I believe if you have followed through, you can be able to do other questions which are similar to this. And I would like to change a gear so that we can move to another question and get to see how can you answer related question to this. And if you are getting value from Provland YouTube channel, consider sharing this video to your friends, to your classmates, Now also you can be able to share it to your social media platforms so that we can be able to reach more students who can also benefit from the same. Express cos theta plus 2 sine theta in the form r cos theta minus alpha, and where we are told r should be greater than 0, and the range for theta is given here, and I believe you are supposed to give the exact values of r and tan theta. Now let's begin. Can you try to do this, because we have done this question from the previous section? Try to do this particular part. See, well, whichever answer I'm going to get is the answer you got. Just pause this video so that you don't see the steps I've done. Attempt it. Once you are done, come back to the video so that we can be able to proceed. I believe you are honest enough to follow those steps, but in this case we are going to write it here. So meaning that if we are to expand this, we can be able to write this as r cos theta cos alpha plus r sin theta sin alpha. So which means that we are going to equate the coefficients. So we can say cos theta equals to r cos theta cos alpha. So we can be able to cancel cos theta both sides. We're going to remain with 1 equals to r cos alpha. And that this is going to become now our first equation. I believe you got that. The next one, we're going to equate this part also on this. So because both of them are having sine, so we can say 2 sine theta equals to r sine theta sine alpha. We can cancel sine theta both sides, and we end up remaining with 2 equals to r sine alpha, and this becomes our second equation. Whenever you are doing this kind of questions, what you need to do, you need to check those areas that you are likely to get it wrong, so that you can be able to mark those areas. Eventually you're going to master everything. Now the next step is to use this equation 1 and equation 2 in order to find the value of r and also the value of alpha. Thereafter we shall express that in the form of r cos theta minus alpha. Moving on, we are going to square the two equations and then add them so that we can be able to find the value of r. So squaring them, this is what we are going to get. Then adding them, we are going to have it written here. So if we add 1 plus 4, this is going to give us 5. We add this also, and then we're going to factor r squared out, so that we are going to have r squared into cos squared alpha plus sine squared alpha. But cos squared alpha plus sine squared alpha is actually 1. So therefore we are going to end up having our value r equal to root 5. The next part that we are going to look at also is finding the value of alpha. In order to find the value of alpha, we are going to divide the two equations. And you can see now from these two equations, if you divide the first equation, rather, you divide the second equation by the first equation, you are going to get this reducing to r cos alpha equals to 1. Then r and r will cancel out. We end up having sine alpha over cos alpha equals to 2. And this part is going to become tan inverse. So tan alpha equals to 2. Therefore, alpha becomes the tan inverse of 2. And this is going to become 1 point. We're going to get 1.107 as the value of alpha. All right, so we can be able to express the function that we had in the form that it's expected according to the question. Then we can also now write the exact value of r which is root 5, and write the exact value of tan alpha, which is 2. So remember, this question also expected us to leave that question at that particular form. We need to move to the next question, and this now becomes the last question that we're going to look at as per this particular tutorial. And we're supposed to express 5 sine theta plus 12 cos theta in the form r cos theta minus alpha. So you need to be careful with the arrangement, and we are given also the range of alpha, and let's go straight ahead and try to follow the steps that we've been discussing all through. Now this becomes 5 sine alpha theta plus 12 cos theta equals to r cos theta minus alpha. So if we expand the right hand side, we're going to get this. All right, so we're going to equate the coefficient of cos and sine theta. Therefore, we can say this part should be equated to that particular part. You need to be careful there because we have equated the last part because both parts are having sine. So that's where we have sine theta. That's where we have sine on the left, on the right and the left hand side. Then we can now say these particular parts should be equated like that, and then we can cancel sine theta. We end up remaining with 5 sine alpha, and that becomes our equation 1. The second part, we equate this term. Yeah, let me just move this a little bit. This term and this term will be equated because both of them are having cos theta, so that we can be able to say these two terms are equal. We can say 12 cos theta equals to r cos theta cos alpha. We can cancel cos theta both sides, which is going to end up to be 12 equals to r cos alpha. Now we have equation 2, meaning that we can now solve the two equations whereby we can be able to get alpha and r. So to find alpha, we need to divide equation 1 by equation 2 in order to obtain the two trigonometric ratios in terms of tan alpha. So which means that we can now divide this as follows, and if we cancel r, we are going to remain with tan alpha, because sine alpha divided by cos alpha is tan alpha. So which means that tan alpha equals to 5/12. Then alpha itself is going to become, just use your calculator at that particular point and see what we can be able to get. So this becomes what? Let's see. You work it out. What you're going to get is actually 0.395 radians. And then we're supposed to find r. So we need to square the two equations and then add them. So that we can be able to cancel the value of the trigonometric function. So this part and this part squared, we're going to get what? If you square 5, it will be 25, r squared sine squared alpha, and if you square 12, you're going to get 144 r squared cos squared alpha. Then adding the two equations, this is going to be, if we add, we're going to get 169, right? Okay, 169 equals to that. Because I've already factored r out, so that I can be able to add the two, and then whatever that is in bracket is going to reduce to 1, so that we are going to remember that the sine squared alpha plus cos squared alpha is 1. Then we can be able to remain with r squared equals to 169, which we find the square root, and our r is 13. Now we are home and dry. Did not because we are going to replace whatever values that we have, because we were told express in that form, so we can be able to replace the values that we have gotten, r and alpha. Alpha is 0.395, which means that our function that we were given, trigonometric function that we were given, can be written in the form that in cos into bracket theta minus 395, 0.395. So that is the form that was expected to be given in this particular question. So I believe now we can move to the next part of the question, because this question usually they come like that. Hence, whatever that you have obtained, you are going to use it to work out the value of x in that given range. So you can see now in the previous section, theta is going to be replaced with 2x. So that's something that you need to be vigilant about. All right, so let us move on and see what we are expected to do here. So we can be able to write this equation on the left hand side on B. 5 sine 2x plus 12 cos 2x can be replaced with whatever that we had obtained in the previous question, but theta will be replaced with 2x. All right, so meaning we can be able to write this expression as 13. We can be able to write this expression as 13 cos, instead of theta we're going to write 2x minus 0.395 is equal to 6, so we can divide both sides by 13, and then we are going to have our question simplifying to that. Right. Whenever you do trigonometric questions whereby you are supposed to find different values of x, before you find the cos inverse, you need to pause at that particular point as if your life depends on it, because this 0.6/13 is very important, because it will enable you know which direction and which trajectory you are going to use in whenever you are finding other angles of x. So what I'm trying to say here is that you need to identify that 6/13 is a positive value. So we are going to find values of x in the quadrant where cosine is positive. So we're going to draw that quadrant there, and now say the solution of x is going to lie where cos is positive, because we know that all students trust Cambridge. Then it means that we can now say this is going to lie in the first quadrant and in the fourth quadrant. That's where cosine is positive. I believe that is well understood. Now, if now we have identified it's going to be in that quadrant, and we have said it will be in the first and the fourth quadrant, we can now go ahead and try to find that principal value of x, the first value of x, which of that particular angle, which is going to be actually finding the cos inverse of 6/13 is going to give us 1.091. So meaning the first value of the angle that we have is 1.091, which is going to be lying at that particular value. The upper part, when you are measuring angles in anti-clockwise direction, those are positive angles. I believe you understand that. And whenever you are measuring angles in the clockwise direction from 0 in the clockwise direction, you see now we're going to have negative 1.091 radians below the x-axis, right? So which means that we can now be able to find the first value of x by using the positive part of that, and this is going to be 2x equals to, so if you divide by 2 both sides, you are going to end up having 1.486 divided by 2, which is going to reduce to 0.743. That's the first value of x that we have. Now, the next value of x that we can work out is the one whereby we are going to add 2 pi. If you add 2 pi, it will be after a full cycle, moving from 0 all the way to 360, again moving all the way. Now, meaning that this is the second cycle. If you add 2 pi, that also will be a solution, which we can also work out. And I'm just showing you that because you may be finding angles after moving a complete revolution and starting another one. Now this is the second one, but if you try to find the value of x using this particular part, you see we're going to divide by 2 here, and the answer is going to be 3.8845 radians, which means that this is out of the range. This is out of the range that we were given, so we are not going to take that. I'm going to show you how to get the other one. So remember, we had gotten negative 1.091 radians. So below that, we are going to say 2 pi minus that. 2 pi minus the angle below here, which is 1.091 radians, which is going to give us what? Another solution. So an angle measured in the clockwise direction is negative, so we can be able to have that as what? If you subtract, we're going to have 5.192, so which means that we can be able to add 0.395 both sides and then divide by 2 both sides, which can enable us work out the value of x, and the second value of x is going to be 2.794 radians. 2.794 radians. So having that, we can decide to leave our answers in terms of correct to 3 decimal places or 2 decimal places. All right, let us just decide and just leave them correct to 2 decimal places, and our answer becomes x equals to 0.74 or x equals to 2.79. If you are getting value from Proflan YouTube channel, consider subscribing so that when we shall be uploading more tutorials on more topics, you will be notified. Share this to your friends so that also they can benefit on the same. See you in the next video.